Hello, my dear students. How are you all? I am fine. I am Khandakar Fazler Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. My dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important mathematical problem from chemistry second paper, chapter 3, Quantitative Chemistry. My dear students, here given our first step, we see that 0.5 gram iron ore dissolved in sulfuric acid in container A, and our question is 22.5 ml 0.02 molar potassium permanganate is required to neutralize completely the solution in the stamp. Now find out the purity of iron in ore. My dear students, when 0.5 gram iron ore dissolved into sulfuric acid, then ferrous sulfate and hydrogen gas is produced. That means iron plus sulfuric acid, then it produces ferrous sulfate and hydrogen gas. Now, this ferrous salt is oxidized by acidic potassium permanganate, then it produces, that means 2K MnO4 plus 10 FeSO4 plus 8H2 SO4 equal to 2 manganese sulfate plus 8H2O plus 5 Fe2 SO4 whole 3 plus K2 SO4. This is the main reaction, my dear students. So, according to the reaction, we can see that 2 mole potassium permanganate reacts with 10 mole ferrous sulfate. So, my dear students, we can write 2 mole potassium permanganate equivalent to, this is equivalent to sign, 10 mole ferrous sulfate. Here sulfate ion is spectator ion, so we can write equivalent to 10 mole Fe2 plus. My dear students, now we can write 1 mole KMnO4, that means potassium permanganate, equivalent to 5 mole ferrous ion according to this relation. And my dear students, we know that what is molar solution? When 1 mole solute is dissolved in 1000 ml solvent, then that is 1 molar solution. So, here we can write 1000 ml 1 molar KMnO4 equivalent to 5 into 55.85 gram Fe2 plus. How can we write this? Because 1 mole iron equal to 55.8 gram, because the molecular mass of iron is 55.85 gram, and here 5 mole ferrous ion is present. So we can write 5 into 55.85 gram Fe2 plus. Now my dear students, here the given potassium permanganate solution is 22.5 ml and concentration is 0.02 molar. So we can write here 22.5 ml 0.02 molar potassium permanganate equivalent to 5 into 55.85 into 22.5 into 0.02 divided by 1000 gram Fe2 plus. So here we get 0.125 gram Fe2 plus. Now my dear students, now we have to calculate the purity of iron, my dear students. So we can say that in 0.5 gram iron ore, 0.125 pure iron is present, and that's why the purity of iron ore is, we get 0.125 divided by out of 0.5 into 100%, and the answer is 25%. So we can say that the purity of iron ore is 25%. My dear students, now we solve our second mathematical problem. Here given in container A 25 ml 0.1 molar oxalic acid, in container B 15 ml potassium permanganate, and in container C here present 12 ml acidic ferrous sulfate. Our question is, calculate the amount of iron of the solution by mixing solution B and C. Here my dear students, we can see that in container B the concentration of potassium permanganate is not given. So at first we have to calculate the concentration of potassium permanganate. How can we calculate the concentration of potassium permanganate? With the help of oxalic acid. My dear students, in an acidic medium, the reaction between oxalic acid and potassium permanganate is 2K MnO4 plus 5 H2 C2O4 plus 3 H2 SO4 equal to 2 manganese sulfate plus 10 CO2 plus K2SO4 plus 8H2O. My dear students, According to this reaction, we can write volume of potassium permanganate into concentration of potassium permanganate divided by volume of oxalic acid into concentration of oxalic acid equal to mole number of potassium permanganate divided by mole number of oxalic acid. My dear students, here for oxalic acid, volume of oxalic acid equal to 25 ml, concentration of oxalic acid equal to 0.1 molar, and mole number of oxalic acid equal to 5. And for potassium permanganate, we can write volume of potassium permanganate equal to 15 ml, concentration of potassium permanganate equal to what, and mole number of potassium permanganate equal to 2. So, my dear students, we can write here volume of potassium permanganate 15 into concentration of potassium permanganate SKMnO4 divided by volume of oxalic acid, this is 25, concentration of oxalic acid, this is 0.1, equal to mole number of potassium permanganate 2 and mole number of oxalic acid, that is 5. So, concentration of potassium permanganate equal to 25 into 0.1 into 2 divided by 15 into 5, and the answer is 0.067 molar. So, my dear students, we can say that the concentration of potassium permanganate is 0.067 molar. Again, my dear students, now the reaction between potassium permanganate and acidic ferrous sulfate, we get 2K MnO4 plus 10 Fe SO4 plus 8H2SO4 equal to 2 manganese sulfate plus 8H2O plus 5 Fe2SO4 whole 3, this is ferric sulfate plus K2SO4. According to this reaction, we can say that 2 mole potassium permanganate reacts with 10 mole ferrous sulfate. So, we can write the relation 2 mole potassium permanganate equivalent to 10 mole ferrous sulfate equivalent to 10 mole ferrous ion. Why we write ferrous ion? Because here sulfate ion is spectator ion, and according to this relation we can also write 1 mole KMnO4 equivalent to 5 mole ferrous ion. And we know that at constant temperature, when 1 mole solute is dissolved in 1000 ml solvent, then that is molar solution, and we can say that is 1 molar solution. So we can write 1000 ml 1 molar KMnO4 equivalent to 5 into 55.85 gram Fe2 plus. Why we write 55.85 gram? Because we know that the molecular mass of iron is 55.85 gram. Here 5 mole ferrous ion is present, so we write here 5 into 55.85 gram iron 2 plus. Now our required potassium permanganate is 15 ml, and concentration of potassium permanganate is 0.067 molar KMnO4 equivalent to 5 into 55.85 into 15 into 0.067 divided by 1000 gram Fe2 plus, and we get the answer is 0.281 gram Fe2 plus. That means the amount of iron in container C is 0.281 gram.